So we're starting Unit 4, and Unit 4 is called The Forces Within Earth. I'm just going to check my volume here now. Okay. So the theory of continental drift is what a lot of people think about when we think about this whole idea of continents moving. And there was a guy named Frank Taylor, and Frank Taylor basically, before Alfred Wegener in 1910, said, you know what, I think continents are actually moving. And they said, oh, really? Like, where'd you get that idea? And he said, well, I kind of think that, you know, India is moving towards Asia, and they're basically colliding into each other. And somebody said, what evidence do you have? And Frank Taylor said, I don't have any evidence. 5 years later, in 1915, a German scientist came along named Alfred Wegener. And Alfred Wegener basically put forth a publication called The Origin of Continents and Oceans. And he basically proposed this idea, you can call it an hypothesis or a theory, whatever, called continental drift. And he basically said, I think that continents are drifting like boats drift through water or icebreakers push through ice. That was his idea. Here's Alfred Wegener in 1912, and like I say, a German meteorologist, so a guy who studies the weather. And I like to think of two boats drifting around in the ocean. One boat is coming towards the other. So just kind of picture two boats pushing towards each other. One's pushing water up, and the other one's pushing water up. Eventually, two boats get together, and the water basically pushes towards each other. So that's the analogy, or even better, two icebreakers. So one icebreaker is pushing ice in front, the other icebreaker is pushing ice in front, and they're pushing or drifting towards each other, and basically you create an ice mountain. And that was his idea for how they actually push the ocean floor up in front and actually creates mountain belts. Alfred Wegener also came up with the idea that he believed that there was a supercontinent 200 million years ago called Pangaea. And he actually did have evidence to support this. So here are little graphics to show what the Earth looked like back in geological time. So if we were to look at this particular diagram here, this is more of the Paleozoic, whereas this is coming into the Mesozoic, and this is into the Mesozoic. And this is at the end of the Mesozoic, when dinosaurs are about to go extinct. And then this here would be into the Cenozoic, which is basically present day. So as you can see, Pangaea split apart into two pieces. Into Jurassic is getting split apart more and more, and then present day in terms of what we have it look like in now. Alfred Wegener proposed 5 pieces of evidence to prove that Pangaea actually did exist. So he basically said if you were to take all the continents, and if you were to just look at them on a map, you'll see that they kind of fit together very nicely. For example, the tip of Brazil fits right into the whole of Africa, or the head of Africa right here fits into the Caribbean Ocean. So a real nice jigsaw fit of the continents. He also done fossil correlation, and if you think about kangaroos, they only live in Australia. They only live in Australia because Australia is not connected to any other piece of land. So when he done fossil correlation, he noticed that there were Mesosaurus, which basically is a large reptile. He noticed that they could be found in South Africa, and they could also be found in Argentina and Uruguay. And so that would only make sense if the two pieces of land were together and the Mesosaurus were roaming around, and then the two continents rifted apart and went their separate ways. He not only done it for the Mesosaurus, he also done it for the Glossopteris. As you can see in this diagram, so the Mesosaurus he done it for the Glossopteris, and he'd done it for a couple others. So you can kind of see the fossil correlation, and you can also see the migration patterns of these different species when they were together as one supercontinent. He also found that folded mountains in the northern part of South America line up with the folded mountains in Africa. They look like two separate mountain systems in the present-day structure of our continents, but when you take Africa and South America and you put them back together, you'll see that they line up perfectly. Also, every continent got a foundation and is typically called a shield. So like in North America, we have the Canadian Shield as our foundation. If you were to look at the shields or the foundations for South America and Africa, they really, really fit together quite well. Not only that, we're looking at South America and Africa here, but if we were to look at folded mountains in northeastern North America called the Appalachians, and if we were to look at mountains up in Scotland and Norway and Finland and Sweden, they're called the Caledonians. When you actually bring North America and Europe back together, they're essentially the same mountains. He also found glacial evidence in certain places like India and Antarctica and the northern part of Australia, southern Africa and southern South America. Some of those places, by the way, you would not expect to find glacial evidence just looking at the present day climates in those areas. For example, India or northern Australia. So when he brought all the pieces back together like a jigsaw, he noticed that when they were together in Pangaea form, that area was covered by a big ice sheet. And so that was one piece of evidence. Then they broke apart and they went their separate ways. He also noted where the different coal deposits were on the different continents. And we know that coal comes from tropical swamps. So when he put them all back together, he noted a correlation in the different continents in terms of where coal deposits were actually found. So that was his 5 pieces of evidence to prove that we actually did have a Pangaea 200 million years ago. The problem that we have with continental drift, we totally believe in Pangaea. We totally have evidence to support Pangaea. But the problem we have with Alfred Wegener is his whole idea in terms of how continents were actually drifting. People asked him how, and he said, I don't have a mechanism to basically support how the continents are moving. He talked about wind, he talked about gravitational pull from the moon and different things like that, but the arguments weren't really strong enough. So as a result, Wegener kind of, I guess, his ideas kind of vanished or didn't have awesome support because of the lack of that mechanism for how they moved.